In this video, what I want to do is do some basic introductory work and provide an overview of what it is we now call AI ethics. Chances are you've heard this term and you've seen it used in the popular media about technology, but understanding what AI ethics is and why it's important is really the goal of this particular presentation. So, what is AI ethics? We can get a definition by looking to your standard Encyclopedia of Philosophy, the Stanford Encyclopedia of Philosophy in this case. And here's how AI ethics is defined. Artificial intelligence and robotics are digital technologies that will have significant impact on the development of humanity in the near future. They have raised fundamental questions about what we should do with these systems, what these systems themselves should do, what risks they involve, and how we can control these. Now, this is a pretty standard definition of what we mean by AI ethics, but what I want to do is provide a little more concrete illustration of what this is all about and why it is important. So I want to start by looking at the way we normally deal with our technologies. And I call this the default setting because this is the way we do things, even when we don't think for ourselves what it is we are doing. It's almost automatic. And the way we normally understand our technology is we look at technology as being a kind of a tool or an instrument that human beings use in order to do something. And in philosophy, there's a very good explanation of this. It's called the instrumental theory or the instrumental definition of technology. And Martin Heidegger, a German philosopher from the mid-20th century, describes it this way. We ask the question concerning technology when we ask what it is. Everyone knows the two statements that answer our question. One says, technology is a means to an end. The other says, technology is a human activity. The two definitions of technology belong together. For deposit ends and procure and utilize the means to them is a human activity. So what Heidegger is basically saying is that for any technology, whether it be something simple like a hammer or something more complex like a computer, it is a tool that we use in order to affect something in our world, either to interact with each other or to do something like build a house or create a transportation system. So often you can look at these technologies as being a kind of medium through which human users act. And they can act on the world or they can act on each other. But the fact is, these are instruments or tools that are neither good nor bad, but it's how they are utilized that makes the difference. You can use a hammer to build a house. That's a good thing. Or you can use a hammer to bash in your neighbor's head. That would be a bad thing. So the tool doesn't really matter here. It's what the human being does with the tool that makes the difference. So the tool is considered neutral. It's considered an instrument. It's considered just a means by which humans do something and decide to act in the world or on each other. But I think we're entering a new normal phase. That is, I think the technologies we're looking at now, especially in artificial intelligence and robotics, are really challenging this instrumentalist understanding of how we explain our technologies to ourselves. And what I want to do is not talk in abstract terms. I want to make this more concrete by looking at two examples where we can see how this new normal is taking shape right now in our current reality. So we have things like autonomous technologies, driving cars that drive themselves, right? We have black box algorithms, which are based on machine learning. And we have social robots, which are robots that are enabled with some AI to enable to interact with us in social circumstances as if they were another social subject. So I don't want to talk about all of these, but I'm going to look at just two in particular. And the first one I want to look at is a algorithm that was created by DeepMind, which is a organization in the UK that's part of Google, and they created a algorithm to play the game of Go. Now, for the longest time, we thought that computers would never achieve the ability to play chess. Then in 1997, they were able to create an algorithm at IBM that beat Garry Kasparov, one of the best chess players in the world. And then in the 2000s, DeepMind did the same thing with the game of Go, which is basically Chinese chess. How complex is Go compared to chess? Well, Go is estimated to have more moves on a single board game of Go than there are atoms in the universe. That's a lot of variables that have to be juggled and negotiated. So is, again, seen as if Go would be this kind of thing the computer could never do, and therefore you would take a lot of creativity and intelligence to play the game of Go, and we would never be able to create an algorithm to achieve that end. Well, AlphaGo did that. In fact, AlphaGo was designed to play the game of Go and do it extremely well. And it proved its ability by beating a South Korean player of the game, one of the best Go players in the world, Lee Sedol. And it took 4 out of 5 games against Lee Sedol. And as a result, proved its capability of being able to play the game Go. Now, what's interesting about this algorithm isn't that it can win. I mean, that's clearly interesting. But what's interesting is the way its architecture is created, because AlphaGo doesn't play the game of Go by following a bunch of cleverly arranged moves that programmers put into its code. AlphaGo evolves its own moves, and it does so by using a very clever architecture that is based on some machine learning capabilities and some good old-fashioned symbolic reasoning approaches. But here's how the engineers at DeepMind described their algorithm. And they say this: our Nature paper published on 28 January 2016 describes the technical details behind a new approach to computer Go that combines Monte Carlo tree search with deep neural networks that have been trained by supervised learning from human expert games and by reinforcement learning from games of self-play. Now, that's a lot of technical information. If you don't know the technology behind deep learning, this may seem a little inaccessible to you. But basically what they did is they set up a neural network, and then they trained the neural network in a number of different ways using what's called both supervised training, but also through reinforcement learning. And in effect, the algorithm learned how to play Go by using this training data that helped it evolve its own approach to gameplay. And as a result of this, the people who designed AlphaGo didn't really know how to play the game of Go. They were just engineers. So all they did is set up the neural network and then feed the neural network on this data and this training approach. And then the algorithm learned how to play Go. So here's how the engineers described what's going on here. They said, although we have programmed this machine to play, we have no idea what moves it will come up with. Its moves are an emergent phenomenon from the training. We just create the data sets and the training algorithms, but the moves it then comes up with are out of our hands. What this means then is that we now have algorithms or AIs that are kind of autonomous or semi-autonomous computer systems that kind of have a mind of their own. In other words, they do things that can surprise us. In fact, in one of the games against Lee Sedol, the algorithm made a move that everyone thought was just absolutely idiotic, like the worst move you can make in the game ever. But it turned out to be so ingenious, so brilliant, that it was the one move that really made the game happen in favor of the algorithm, and that's when it beat Lee Sedol. So oftentimes we create these algorithms now that we don't know what they're going to do until they actually do it. When it's a good thing, like winning a game of Go, it's nice and surprising. But when it's a bad thing, like a self-driving vehicle striking a pedestrian, it is less good for us as developers and engineers to not know what is actually happening inside the box. That's why these algorithms are also often called black boxes, because we don't know what happens inside the box necessarily. All we know that is information goes in one side and results come out the other side. And so, especially with deep learning, when you're training it on large data sets, we have a situation where we get algorithms that are very capable, but oftentimes even the developers don't know what's happening inside the box. The second example is something that happened in June of 2022. This is when a former Google engineer named Blake Lemoine was working with the new Lambda large language model that Google was developing. And in the process of interacting with Lambda, Lemoyne determined that the lambda system was conscious, and therefore it was a person deserving of moral respect and being treated as if it were another kind of sentient creature like ourselves. Google obviously did not agree, and they argued quite the opposite, that it's not a person, it's a thing. So what you see here is a dispute between Lemoyne on the one hand saying that the algorithm is conscious, it's a person, it has moral and legal standing, it has rights and responsibilities. And on the other hand, you have Google saying, no, it's just a thing, it's an object that we can use and even abuse as we see fit. And therefore, we don't have to accord to it any moral status that's different than, say, our toaster for that matter. This was never resolved. In fact, the entire dispute was ended when Google fired Blake Lemoyne. But you can see the tension here between an algorithm that gets to be very capable in its use of language, convincing someone very intelligent like Lemoyne that it is an actual person and not a thing. And Google, on the other hand, arguing, no, it's not a person, but it is a thing, mainly because they want to retain it as their property. And this tension between person and thing is very old. It goes back to Roman law, but it means that we have situations now with our algorithms where we have a kind of inability to decide necessarily whether they are things that can be used or whether they are a kind of person to which we have to accord some kind of respect and consideration. So given these new algorithms, this new normal I'm talking about, what are the possible responses we could have? And this is where AI ethics really begins to fill out the picture. So in response to these challenges, we can go back to instrumentalism and reassert the standard instrumentalist theory and say, no, no matter what, they're just tools. That's kind of what Google was trying to do with Blake Lemoyne. Or we can say, no, we should maybe think about these things as being moral subjects, as being maybe not persons, but at least a kind of thing that it's more than just a thing. It's kind of occupying the position of another moral subject that needs to have some modicum of respect, some access to rights and responsibilities. In the field of AI ethics, this is often called machine ethics. And lastly, we can try to get a kind of in-between position, which I call a hybrid solution. And that's where we distribute responsibility and rights across the network of interacting human and machine components in a way to try to balance the difference between instrumentalism on the one hand and machine ethics on the other hand. The instrumentalist approach is very popular. You can see it already taking place in a lot of the legislation that is being discussed worldwide, especially the EU's recent AI Act. Here's one version of it called the principle of robotics. They write this: robots are simply tools of various kinds, albeit very special tools, and the responsibility of making sure they behave well must always lie with human beings. Very strict application of the instrumentalist way of thinking, saying no matter how intelligent the AI seems to be, it's always a human being that's in charge. There's always a person behind the algorithm that is responsible for what it does, and you can never hold the algorithm itself responsible for something that is done by way of that technology. So a very standard instrumentalist way of thinking. On the other extreme, you have this machine ethics way of thinking. And this has been developing in the last several decades. And it's an attempt to recognize that some level of moral or legal responsibility can and should be attributed to the machine. That in the case of something like AlphaGo, you don't know who to credit the win to. When AlphaGo beat Lee Sedol, the journalists didn't know who won. Was it the engineers at the company that built it that won the game? Was it the data and all that information that was fed into the algorithm, or was it the algorithm itself that actually beat Lee Sedol? That's where machine ethics comes into play, and it says in some cases the algorithm may need to be held accountable. The algorithm will be the responsible party for the actions that it undertakes. Now, both of those are extremes. One on this hand with instrumentalism, on the other hand, machine ethics. And some people have argued, well, those are two extremes. Maybe we need to do something down the middle. Maybe we need to have something that balances these two extremes. This is a kind of hybrid solution. And Deborah Johnson describes it this way. When computer systems behave, there's a triad of intentionality at work. The intentionality of the computer system designer, the intentionality of the system, and the intentionality of the user. So in this hybrid approach, we're trying to sort of split the difference and say, well, it's not fully all human and it's not fully all machine, but it's a combination of some human activity and some machinic activity. Now, this gives us a spectrum or a way of looking at different ways of organizing these technologies. And that spectrum runs on the one end from instrumentalism in a very strict sense, on the other side to machine ethics, and then down the middle, this hybrid solution. And so the real task of artificial intelligence ethics or AI ethics is to try to figure out how we are going to resolve these questions regarding responsibility and rights when it involves our technologies. Can we go back to the old way of doing things and be fully instrumentalists? Or do we have to begin thinking about machine ethics as a possibility with these new algorithms that are more capable than our previous technologies? Or is maybe that going too far and we need something that's a little more balanced down the middle? Obviously, this is the debate right now that really shapes the field of AI ethics, and different researchers, different scholars occupy different positions along this spectrum. But I would say when you're reading about AI and you're looking at it from a perspective of ethics, this is the thing to think about, that we are trying to figure out where to fit these technologies on the spectrum. And that is a decision that is not only made by individuals, but it's also made by communities, nation states, and even industries. And that's the debate that is going on currently right now under the rubric of AI ethics.